Hello everyone, welcome to my channel. Today we are going to discuss about Schrodinger wave equation, that is Schrodinger time dependent and time independent equation. Okay, it's an important essay question from module 3, that is quantum mechanics chapter. Let's see. So Schrodinger wave equation, time independent equation, that is a fundamental equation of quantum mechanics, and here for explaining this time independent Schrodinger equation, let us consider a particle moving forward along x direction with a linear momentum p. And for such particle that is moving along x direction, that is in one-dimensional motion, the wave function, or before that, the differential equation for that wave can be expressed as dou square psi by dou x square is equal to 1 by v square into dou square psi by dou t square. എന്താണ് ഈ വൺ ഡയമെൻഷണൽ വേവ് ഇക്വേഷന് മൂവ് ചെയ്യുന്ന ഒരു പാർട്ടിക്കിളിനെ നമുക്ക് ഡിഫറൻഷ്യൽ ഇക്വേഷൻ അതിൻ്റെ എക്സ്പ്രസ് ചെയ്യാൻ പറ്റുന്ന ഒരു ഇക്വേഷനാണ് നമ്മളിപ്പോൾ പറഞ്ഞത്. എന്താണ് ഡോ സ്ക്വയർ സൈ ബൈ ഡോ എക്സ് സ്ക്വയർ ഇസ് ഈക്വൽ ടു 1 by v square into dou square psi by dou t square, where psi is the wave function. So put it as equation number 1. The solution of this equation 1 can be written as in different forms, that is in sine form, cosine form, or in exponential form. Okay, so that is the solution is the wave function. Solution dou square psi by dou x square എന്ന് പറയുമ്പോൾ അതിന്റെ solution is represented as a psi. So the wave function of the particle can be written in terms of sine function or cosine function or exponential function. In terms of sine function, it can be written as psi is equal to a sine omega t minus kx. Put it as equation number 2, or it can be written as psi is equal to a cos omega t minus kx. That is equation 3. Or it can be written as psi is equal to a e raised to minus I into omega t minus kx. Put it as equation number 4. Okay, here to explain this or to derive this Schrodinger equation, we are going to consider this exponential wave function or the solution. Okay, exponential equation 4 ആണ് നമ്മൾ ഇവിടെ consider ചെയ്യാൻ പോകുന്നത്. So for that, in this equation 4, you can see there is omega that is equal to 2 pi by t, where t is the time period. So we know that 1 by time period or the reciprocal of time period is frequency. So I can write that equation in terms of 2 pi nu, or it can be written as എനിക്ക് ഒമേഗ എന്ന് പറയുന്ന ടേമിനെ എനർജിയുടെ ടേംസിൽ കൺവേർട്ട് ചെയ്ത് എഴുതണം. സോ ഐ ക്യാൻ റൈറ്റ് 2 pi into ന്യൂനൊപ്പം ഐ മൾട്ടിപ്ലൈ by h and also divided by h. So I can write it as 2 pi h nu. H nu is energy E divided by h by 2 pi, that is h cut. So omega is equal to E by h cross. Okay, put it as equation number 5. Similarly, propagation constant K, that is equal to 2 pi by lambda, where lambda is the de Broglie wavelength, and we know de Broglie wavelength lambda is equal to h by p. So substituting that value here, that is 2 pi by h by p, p becomes the numerator, p comes to the numerator and h will be in denominator. So I can write p by h cut, where h cut is h by 2 pi. Put it as equation number 6. Now substituting equations 5 and 6 in equation 4. ഈ 5ഉം 6ഉം നമ്മൾ 4ലേക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാൻ പോവുകയാണ്. ആൻഡ് യു ക്യാൻ സീ psi is equal to a into e raised to minus I into, instead of omega I can write E by h cross into t, minus instead of k I can write p by h cross into x. So inside the bracket there is a common factor divided by h cut. So I can take that h cut outside. So the equation will become, or the solution of this differential equation will become psi is equal to a e raised to minus I by h cross et minus px. Put it as equation number 7. This is our equation to derive Schrodinger wave equation. Okay. So taking this equation 7, we are going to differentiate this equation 7 with respect to t once. Okay. So psi നെ ഞാൻ ഒരു തവണ t വെച്ച് differentiate ചെയ്യാൻ പോവാണ്. That is dou psi by dou t. Or it can be written as, നിങ്ങൾക്ക് തന്നെ ചെയ്ത് നോക്കാം. Try to do it by yourself. That is dou psi by dou t is equal to, what will happen? t എവിടെയാണ് ഇതിനകത്ത് ഇക്വേഷനിലുള്ളത്? It is related to et. So I can take the exponential function. You know that e raised to ax is a e raised to ax, or e raised to alpha x is where alpha is a constant, then we can differentiate it as alpha e raised to alpha x. Similarly, here there is e raised to minus I by h cross et minus px. So in terms of t, when I differentiate it, what will be the answer? I can take the constant terms outside. In terms of t, there is constant terms minus I by h cross into e. So I can take that outside into a is a constant into e raised to minus I by h cross et minus px. Clear? So this a e raised to minus I by h cross et minus px is simply psi. So I can substitute directly as psi. So our dou psi by dou t equation will be is equal to minus I e by h cross psi. From that I can write, I need to take energy E psi. Okay? E psi എന്നുള്ള condition അല്ലെങ്കിൽ ആ ഒരു equation എനിക്ക് ഈ ഒരു സാധനത്തിൽ നിന്ന് അല്ലെങ്കിൽ ഈ ഒരു equation നിന്ന് എനിക്ക് വേണം. So for that, from this equation I can write E psi is equal to, I can take this h cross on this side, that is h cross divided by minus I into dou psi by dou t, that is equal to E psi. Or E psi is I h cross dou psi by dou t. എങ്ങനെ കിട്ടി? 1 divided by minus I into I or I square is minus 1 or minus 1 by I is I. So here there is h cross divided by minus I, that is 1 by minus I. 1 by minus I is simply I. So I can write E psi is equal to I h cross dou psi by dou t. Put it as equation number 8. This is our energy equation. Okay, energy wave function. Here you can see this energy act as an operator to this wave function. Okay, so for that, as the psi is the wave function and energy is acting as the operator, we can see the value of this energy operator E is equal to, or the term of this energy operator E is equal to I h cross dou by dou t. Psiയിൽ ഓപ്പറേറ്റ് ചെയ്യുന്ന ഒരു എനർജി ഫംഗ്ഷൻ അല്ലെങ്കിൽ എനർജി ഓപ്പറേറ്റർ ആണ് ഈ ഇ എന്ന് കാണിച്ചിരിക്കുന്നത്. അതിന് നമുക്കൊരു വാല്യൂ ഇവിടെ പറയുന്നുണ്ട്, ദാറ്റ് ഈസ് ഐ എച്ച് ക്രോസ് ഡോ ബൈ ഡോ ടി. അതാണ് ഇയുടെ ഇവിടുത്തെ ടേം. ഓക്കെ, പുട്ട് ഇറ്റ് ആസ് ഇക്വേഷൻ നമ്പർ 8. Now we need to differentiate this solution equation with respect to x twice to get the momentum equation. Momentum related to equation നമുക്ക് വേണം. അതിനുവേണ്ടി ആദ്യം ഒരു തവണ എക്സുമായിട്ട് ഡിഫറൻഷിയേറ്റ് ചെയ്യുന്നു. Again differentiating the same equation, you will get dou square psi. Okay, first of all let's see dou psi by dou x. Dou psi by dou x നേരത്തെ ചെയ്തതുപോലെ e raised to alpha x is alpha e raised to alpha x. Similarly here I can take in terms of x ആരൊക്കെ കോൺസ്റ്റൻസ് ഉണ്ടെന്ന് നോക്കുക. Who are they? There are constants like minus I by h cross minus p, minus I by h cross into minus p. So I can take it as minus into minus, it is plus, that is I by h cross into p. അതല്ലേ ഇവിടെ എഴുതിയേക്കുന്നത് ip by h cross. Okay, into the constant a into the exponential function e raised to minus I by h cross et minus px. Taking the second order derivative, അല്ലെങ്കിൽ second differentiation എടുക്കുക, dou square psi by dou x square, that is equal to, again differentiating this above equation. ഈ തൊട്ട് മുകളിൽ എഴുതിയ equation once again we differentiate it. So what will happen? These terms are constants. Ip by h cross into a, I can write it as such. Again differentiating exponential function. What will happen? Minus I by h cross into minus p. അത് പിന്നെയും വരും അല്ലേ, minus into minus plus ip by h cross. ബാക്കി exponential function as such. Clear? So ip by h cross into ip by h cross is I square p square by h cross square into the other terms are related to psi. So I can simply write it as psi. Here I square is minus 1. ആണേ, നമുക്കറിയാം മാത്സിൽ നിങ്ങൾ പഠിക്കുന്നതാണ്. So minus into p square divided by h cross square into psi. From that I can write p square psi is equal to minus h cross square into dou square psi by dou x square. This is our momentum related equation. Here you can see this momentum p square also is acting in terms of wave function as an operator. Okay, so for quantum mechanics you can see there are two main operators, energy operator and the momentum operator, that you will study later. Okay, so this equation can be written as equation number 9. Is it clear? Let's move on to the next slide. So now we are going to take the total energy of the particle, that is the sum of kinetic energy and potential energy, that is E is equal to P square by 2m plus V, kinetic energy plus potential energy. And multiplying by psi to this total energy equation, you will get it as E psi is equal to P square psi by 2m plus V psi. Put it as equation number 10. ഇനി എന്താ ചെയ്യേണ്ടേ? Look at this equation. We know the terms or the values for this E psi and P square psi. Earlier we found that equations, അല്ലേ? E psi യും P square psi യും കണ്ടുപിടിച്ച് വെച്ചിട്ടുണ്ട് മുന്നത്തെ സ്ലൈഡിൽ. So I can substitute that values of E psi and P square psi here. So instead of E psi I can write IH cross dou psi by dou t is equal to, instead of P square psi I can write minus H cross square into dou square psi by dou x square divided by 2m. Plus V psi as such. Potential energy നമുക്ക് വേറെ കണ്ടിട്ടില്ല, നമ്മൾ V എന്ന് തന്നെയാണ് potential energy represent ചെയ്യുന്നത്, so I can write it as such. So this equation 11 is the one-dimensional time-dependent Schrodinger equation. You can see there is a factor related to time, dou psi by dou t. So that's why this equation is called one-dimensional time-dependent Schrodinger equation. Okay? And this is for one-dimensional case. If it is three-dimensional case, what will be the answer? It will be minus h cross square by 2m into dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. Instead of taking all these three terms, x, y, z എന്നുള്ള positions മൂന്നും എടുക്കുന്നതിന് പകരം I can write in general as I h cross dou psi by dou t is equal to minus h cross square by 2m into del square psi plus V psi. Instead of dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, I can write general as del square. So this equation 12 is the three-dimensional time-independent Schrodinger equation. So I hope time-independent Schrodinger is clear for all of you. Thank you for watching. Time